All right. So this is week one, Friday. This is your study guide for geometry statements. Quarter two, math 7. All right, so true or false? A conditional statement, if then, and its contraterm are logically equivalent. So you want to write this down. A conditional statement is if P, then Q, right? And then the contrapositive if no, I don't think they're logically equivalent. If not Q, then not P. I think it's false. Well, that's okay. Did you ask AI if it's true? See, good question. Okay. Is conditional statement logically equivalent? Is that what it says? To logically equivalent to contrapositive? No. Oh, it is true. Yes, yes. A conditional statement is logically equivalent to its contrapositive. A conditional statement has the form if P then Q denotes P then Q, right? Contrapositive is if not Q then not P denotes as that. Both the original conditional statement and its contrapositive will always have the same true value, meaning they are logically equivalent. I don't know. I mean, I don't know. Like that. I mean, sure. So hold on a second. Let's put true or false. I don't. Well, I guess if it's not Q, then not P is like the reversal of it. So I don't know. I don't freaking know.
Well, I mean, it goes like, no, it's not.
But it is correct apparently. So if it's correct, I'm gonna trust it. I don't fucking know.
Because then I'm definitely gonna fail the test. I'm gonna fail the test like all the other freaking tests I did.
No, you're not. You're not. This was the whole class of better.
Yeah. Basic stems.
No. Okay. So this is the reason why. Okay. So the way I think about it is like, okay. So if P, then Q, right? If there is a not involved, then you can go ahead and reverse because remember, if it's not Q, then not P, it will reverse that. When it reverses that, I guess that with then it becomes a P, then Q. Does that make sense? Okay. So just reverse it. So it's true. So just put true. So just remember, if she has this question again, just put true. Okay. All right. They're logically equivalent. Okay. Definition are always, there's this a biconditional. I don't even know. Okay. Let's check it out. Are biconditional statements. What does it say? Are biconditional statement what? Wait, so what does it say? Oh, definition always. Are definitions always biconditional? Is that what it says? No, but I want to make sure I use exact wording. Definition is always conditional. Okay, so biconditional, remember, is P if and only if Q, right?
When both the conditional and its contrapositive.
Right. So that's are always. I think that's true. Definitely always biconditional. Let's see. Statements question. Let's see. Yes, and so it is true. It's true. Because remember, okay, biconditional is a condition, right? So if P then Q, right? That's going forward. And then there's always the converse, which is if Q then P, right? So a definition has to be forward and backwards. Okay. So yes, definition typically expresses by conditional statement. This means that if a definition can be stated in the form A, if, and only if B, this indicates that both the condition and its converse are true, establishing a two-way logical relationship. So for example, a figure is a square if and only if it's a quadrilateral with 4 equal sides and 4 right angles is a biconditional statement. So, okay, so I guess we'll just use that then.
Wait, so it's doing P if and only if.
So the way I kind of like break this down is like definitions. Okay, so if P then Q, right, is true, correct? And then the converse, if Q then P is true. So a definition, you have to go forward and backwards. Both the forward and backward has to be true. So it is true. Does that make sense? So I have an explanation of that, which I'm gonna post right here for you. I need to make it a little smaller, of course. Better not be a little. I know, funny. I'm sorry. Here, there we go. This is your.
Because we're not.
Yeah. Okay. Okay. The then part of a conditional statement is called a hypothesis. That's a conclusion, isn't it? Yeah. Okay. So that's good. Okay. So the then part of this is actually a conclusion, right? The if part is the hypothesis. So make sure you write that down so that way you know. Okay. All right. Make a conjecture about the next term in the sequence. So 92, 87. So what is happening here? What's going on? What are they adding or subtracting? How do you get 92 to 87? Subtract 5. Is that it? So 72 minus 5 is going to be a 67, right?
Yeah.
Then subtract 5 again. Okay. Make a conjecture about the next term in the sequence. Make a conjecture. You need to write it down. You just say the pattern is minus 5. Don't erase it from the previous term, right? The sequence is 67, which is the next numbers. 62, 57, 52. Okay, next one. First thing you want to do, you want to make sure you find the P and the Q, right? What is your P?
My P is if two angles are complementary,
Good. What's your Q?
then they are adjacent.
Good. So the converse, remember, is if Q then P, right? So if two angles are adjacent, they're complementary. Good job. Okay. Write a contrapositive. So if not Q, then not P. Good. Okay. Write an inverse. So if not P, then not Q. Awesome. Good job. Give a counter example for the conjunction. If x squared equals 4, then x equals 2, right? Equals 4.
If x equals to x squared.
Counter. Yeah, I can check that one. Yeah. For and if you're not sure, you can always search, right? What is a counter example to? And what you want to do is you want to put quotes there. If was an x squared
X
where
equals
equals 4.
then x.
Okay. Fine. Okay, then x equals 2. And then okay.
Why is it negative?
Oh, because here's the other thing. Okay, so x squared equals 4, right? When you solve for this, don't you have the square root of both sides? when you square both sides, x equals plus and minus 2. There's a positive 2 and negative 2. Because if x equals positive 2, x squared is 2 times 2, which is 4, right? But if x equals negative 2, that's the same thing. Negative 2 squared is negative 2 times negative 2, which is also 4, right? So if x equals, so here what you should do is if x equals negative 2, then x squared equals 4. Or you just put if x equals negative 2 or x equals positive 2, then x squared equals 4. So include both. I think both of them. So include both of them. Oops.
Okay. Okay. If 7A is a
If a car is out of gas, then will not start. Fact, Kelly's car started. So then the conclusion is that's not gas. What is that?
that's supposed to say gas.
If Kelly's car has gas, then the car will start. Is this her? Her.
That's yeah, that
Okay. If you have your learner permit, then you will drive. If you have your driver, Mary got her learner permit, then she will drive with her parent, right? If Mary got her learner permit, then she will drive with her parent. Good job. All right, cool. Sounds good. Okay, we're almost done. We're done. Okay, the midpoint of PQ. So here we go. PQ. So is PQ a segment or a line? That's okay. So this is a segment, right? It's a segment because you see how it's not a line. If it's a line, it will have something like this, right? If it's a ray, it will have something like this, right? So this right here is a segment. Do you see that? It's important to notice that. So T is the midpoint. What's the definition of a midpoint? Midpoint splits a segment into what? It splits it into T equal segment. Like this part right here is equal to this part right here. That's what I'm talking about, right? Okay. So then which one has to be true? Well, let's take a look at this, okay? PT equals TQ. That is true. Do you see that? Okay. PT is equal to TQ. Wait, hold on a second, because no, this is correct. This is correct.
he said it's not.
Because it's not what? Congruent, but doesn't that they say equal to?
No, C has like that the different.
Okay, I guess if it's a segment, if it has a segment, array, or a line, you have to have congruent, okay? This one has no segment, right? So you can do equal. Does that make sense? But this one is equal, but it has a segment, so it has to have, I guess that's the. Okay, so here's the thing. Do you see how for D, there is no segment? So you can use the equal sign. I think that's her thing. Okay. So C, it is a segment, so have to use the congruent sign. Does that make sense? So just remember that. Okay, that's kind of a silly thing, but whatever. It's fine. Can you write a statement as a conditional and make valid conclusions based on the chain of conditional statements? Write the converse, inverse, and contrapositive of the statement below. That's fine. So I'm gonna pause them right now, so then you can go play with your brothers for a little bit, and then I want you to finish this. Does that make sense? All right, so let's continue. So we already figured that out. So just as a review for this last one, remember that if there is a segment, ray, or and actually this one right here, if using segment, which is this, right? Ray,
put it down,
which is this, or line, which is this, right?
Yeah.
Use congruent, okay?
Yeah.
If it's not that, then use equal sign. Does that make sense? So congruent is for geometry symbols, and so just make sure you have them. Can you write a statement as a conditional? So conditional is if P, then Q. And then make a valid conclusion based on the chain of conditional statements. When it says chain of conditional statements, oh, that means you're gonna have to do the converse, right? So if Q, then P, right? I like to write everything out just so I know what I'm using, okay? And then you have to do the inverse. So if not P, then not Q. And by the way, I want to know this means congruent, right? This means what? Equal. Did you actually try to go over symbols with you in geometry? That would have been a good one. That's okay. And then do you know what this means?
If something else.
If then, okay, do you know what this means? Not, okay? So these are all symbols. This is important. So make sure you copy this now. In your notebook. Do you have your notebook?
No.
Go grab your notebook. Symbols and geometry. And I'll pause and I'll wait for you. You're welcome. Oh, 15. Write the converse, inverse, contrapositive, of true statement below. Say whether it is true or false. Oh, one more thing. This one. You gotta make sure you include this one. This is P. This just means if and only. If and only if. And remember, this is just for the by conditional statement. Okay. Yeah, but those are all the symbols in geometry. Okay, so let's take a look at number 15. If 4 points are not coplanar, then they are not collinear. Okay, so then let's go ahead. 4 points are not coplanar, right? That is going to be your P. Do you agree with that? Okay. Then they are not collinear. So this part right here is Q. Okay. You gotta be careful when you do the not, because you see how this is all like already negative, right? So if you do a not coplanar, then it becomes a positive. Do you see that? So if it's like a not coplanar, where it's a double negative, you want to write this down. That is equal to a positive. So it's coplanar. You want to be careful with that because when you start doing the inverse, which is like if not P, then not Q, and when you do the contrapositive, if not P, Q, and then not P, you gotta negate that. Do you see that? Negative of a negative is a positive. Okay, so make sure you're careful with that when you're writing it. So just this part right here that is highlighted in yellow, not coplanar, double negative equals positive, which means it's coplanar. Do you like these? No. No. Oh, I like it. Flip fiber, so it helps you improve. Okay. All right. So this is not enough. You need to give you more space to write it. That's okay. I'm gonna type it up right here. Are you ready? What's the conditional statement for this? Yeah. If for what? Comma. And then what do you say after that? They are no. If hold on a second. If 4 points are not, remember the P is if 4 points are not coplanar.
Is that conditional?
I think so. Because conditional will be if P then Q. Then they are also not. What is it? They are not one. collinear. Although I want to make sure that this is correct. So let me check. Okay, so I want to be sure. Let's just check. You see how if I'm not sure, then I'm just gonna go ahead and do it. So oh yeah, so it is like so it says it right here. Given a statement that this is what it is, right? P is 4 points are not coplanar, so we don't change anything, right? Q is they are not collinear. So the statement is already in the form of a conditional statement. If 4 points are not coplanar, then they are not collinear. Does that make sense?
Yeah, and the conditional is if P then Q.
If P then Q, right? Okay, so then this is correct. Do you agree with that? So you don't change the not because the not is the P, right? It's already in the P. You don't change it. But what you are going to change is when you do the inverse and there's like a not, then you have to switch it to a positive. Does that make sense? Okay, so let's go ahead and keep it as is because that's going to be your conditional. Oops. Okay, so the next one is going to be what? Converse, right? Converse is what?
If not Q, then not Q.
If no. Converse is backwards. There's no not. You gotta memorize this.
If and then Q.
Okay, so rephrase it. What would you say?
If 4 points are not collinear, then they are not coplanar.
Yeah, if 4 points are not collinear, they're not coplanar. If 4 points are not, and it's good that you put the collinear first, because that's the first part, right?
Yeah.
Then make sure you write it down. They are not, and make sure it's backwards, coplanar. Because when you check this, you just want to make sure that the converse is backward from the conditional. Does that make sense?
Yeah.
Okay. Let's go. Coplanar. No, it's not the same. Okay. All right. What is the inverse going to be?
If 4 points are
Think about the P and the Q first.
not P, then Q.
If no feeling else, that's not backwards. It's just opposite, right? It's not backwards, forward,
If
right?
4 points are coplanar, then they are collinear.
Yeah. Go to the conditional and just write it, but make sure it's negated, okay? If 4 points are coplanar, then what?
Then they are collinear.
Yeah, perfect. Negative cancels, right? And then make sure there's a then. And just to make sure you're checking with us, when you check this, make sure that the inverse is just like the conditional, except the only difference is that there is a negative. Does that make sense?
Yeah.
Okay. So this is inverse, right? Yeah, let's change it to different colors to see a little bit better. I don't think it's okay. Last one. What's the last one? What is it?
Right.
Nope.
Contrapositive.
Yeah, contrapositive is what? Give me the statement.
If not Q, then not P.
Yeah, it's like the inverse, but just backwards, right? Or it is like the converse, which is backwards already, but you just need to put a negative to it, right? Okay, so what do you say, Mary?
If 4 points are collinear, then they're coplanar.
They're collinear, right? Okay, good. All right. Now that we're done with everything here. Let's take a look and see what we have next. And it says that write the converse and mirror of those true statement below. State whether each is true, false, and explain why. So we do have to explain. Okay, so do you need some extra paper right there? Or maybe you'll write it down here and just draw an arrow. Okay. Conditional, true or false. Your 4 points are not coplanar, which means they're not on the same plane, right? And they're not on the same line.
False.
I think it might be true, but just to make sure, we can go over here and we can find out, okay? I mean, you do have this as a possibility, right? So use AI to your benefit, but don't take advantage of it, obviously, right? I think it's true. True. Yeah. It is true. If 4 points are not coplanar, which means they're not on the same plane, then they cannot lie on the same line, right? Meaning they're not collinear. Okay, so if they don't lie on the same plane, then they're not on the same line. Okay, being collinear implies that all points lie on a single straight line, which means they also have to be coplanar. So you might want to write that part in. Okay, being collinear implies that all points lie on a straight line, but they also have to be on the same plane. So if they're not on the same plane, they are not on the same line. So that is something that you need to put in your notebook. No, your notebook. So that way you have that.
Highlight it. Oh.
Yeah. So this is a rule, okay? So I'm just gonna put a rule, put semicolon, so that way you know. And I'll highlight it for you. So if they're on the same line, they have to be on the same plane, okay? And if they're not on the same plane, then they're not on the same line. Does that make sense?
Yeah.
All right. Emma. Let's see. Okay, so then on the first one right here, 4 points are not coplanar, that they are not collinear. True or false? True, because why?
Because being collinear implies that all points lie on the same line, which means they must also be a coplanar.
Yeah, so then you can go ahead and just use that as your reason. Does that make sense? So you want to write it down. So maybe draw an arrow and just say true, because if 4 points are not on the same plane, then they're definitely not on the same line. Okay, does that make sense though?
Yeah.
Okay, so you could do that.
It's true.
If 4 points are not collinear, they're not, yeah, if they're not on the same line, they're not on the same plane. Because, what did you use as an example? Because why?
I kind of like this did the opposite with like the conditional. If they have to be on the same page. Or line. If they're not on the same. If they're not
So
on
the
same,
converse is
they're not on the
probably
same
true.
plane.
Oh, no, 4. It's false. If 4 points are not on the same line, it's, oh, they could still land on the same plane. That is technically true. So like if they're not collinear, which means they're not on the same line, right? They can still be on the same plane. So that one is false. And here's why. If 4 are not the same line, they are not coplanar. So here's what is it? Do you see how this is the same plane? This is plane B. Do you see that?
Yeah.
Okay. Now, I have A, C, D. Do you see that?
Yeah.
Those 3 points, they lie on the same line. Do you see that?
Yeah.
But then I'm going to put E right here. E is still on the same plane, but it's not on the same line. You see that? So then this one is false. Do you see why though?
Yeah.
Good. So then write about that. So false because, well, there's a diagram right there, right? Because points can lie on the same plane and what? Not be on the same line. Do you see that?
Yeah.
Okay. Fine, dots. PG, that's 30 points. Okay. Does that make sense though?
Yeah.
So that is going to be your converse. Okay. This is your conditional. All right. What did you say for the next one? Inverse.
I said true.
If 4 points are on the same plane, that's false. Okay. 4 points can be on the same plane, but they don't have to be on the same one. Right? Like, look at the picture. Do you see how A, B, D, E are on the same plane? Do they have to be on the same line? No. I mean, I can also draw another plane. Like, this is called plane L, right? I mean, isn't it possible for me to draw X? Oh my God, color can see. X, Y, Z, K. Do you see that right there?
Yeah.
Like, they're all on the same plane, but they're not on the same line. So this one, I don't even have to search it up. Just use like common reasoning. It's false. Because why?
Because it's not on the line, but it's still the same plane.
Because points can be on the same plane and what? Not the same line, right? Okay. Okay, contrapositive. If 4 points are on the same line, then they are on the same plane. I think that is true. If they're on the same line, they are on the same plane. Well, let me see if that's true. That does make sense to me, but no. Or false. True. If 4 points are on the same line, they lie on the same straight line. A line by definition lie in a plane. Therefore, any set of collinear points must also be coplanar. as they all reside on the same time. Does that make sense? Okay, so then you go ahead and write the explanation for that. So this one is true. One. True. And then you write the because, blah, blah, blah. Oops. Okay. Are we okay with this now? Did you write that answer down? Do you need a moment to write it down? All right, so let's go ahead and, oh, hold on a second, we're not done. Next one. All right, number 16, right? Decide if the argument is valid or invalid and explain why.
Valid, because there is no.
But you gotta write the, oh, hold on, okay. If today is a holiday, then we do not have school. Today is not a holiday, therefore we do have school. It is valid, right? Why?
Because there's no holiday.
So you go to school, right? Yeah, okay, so you're, okay, fine. 17, when can you make a biconditional statement?
When both the conditional and its converse are true.
When can you make a biconditional statement? I don't even know what that question. Okay, let's just
That's
ask.
my best guess.
Yeah, that would be my guess. When can you make a
No, go away, go away. I hate you.
biconditional statement?
I hate you.
Stop it.
You keep provoking me. And then
There's gonna be a lot of people that provokes you, so I suggest you stop.
He's the one that
A biconditional statement can be made when both a conditional statement and its converse are true. So good job. A biconditional statement is typically written in the form A if and only if B, which is like this symbol right there. Do you see that with a little double arrow? Okay. This indicates that if A then B, which is a conditional statement, and if B then A, which is the converse, right? Both direction of the statement must hold true for a biconditional statement to be valid. So the only thing I would go ahead and add is if P. So you just put P then Q and Q then P are true. Oh, true.
Yeah.
You write this part right here?
Yeah.
Okay, so what on this? Find the missing angles and yeah.
This one. It's so easy that everybody else can like kind of struggles with.
That's okay. Let's just practice with this. So let's look at the parallel lines first. Which lines do you feel like is parallel?
48 and H or H.
Well, I don't know that, but this line right here, right?
Oh,
These two lines are parallel. Which one's gonna be your transversal?
You move her shirt somewhere.
What
She
shirt
has
is
no shirts. One of the shirts has pants.
yeah, I get. I feel like all I think you need to practice with your alternate interior towards angle one. I feel like you need to practice with that. Okay. So you need to watch that video a little bit more. Do you understand me? Which one's your transversal that cuts through this? It's this line right here. Do you see that?
oh.
Do you see that? Although another transversal could also be this line as well. You see that? So on the side here, let's just review something. Okay, remember, there are four things. There is the corresponding angle. Do you see that? So on your note on your right, corresponding. And you do?
Something.
Okay, you need to memorize that then. So let's do it this way. Here, I'm gonna just practice with you. Do you see this right here? This is gonna be 1, 2, 3, 4, 5, 6, 7, 8. Do you see that? So draw that. 1 on the For one, write corresponding angles. Okay? These angles are congruent, which means they're equal. Okay?
Yeah.
It doesn't need to be that big, but that's fine. So which one are corresponding angles? And list them. Keep listening them. You're gonna list them. Alright.
Wait, I'm asking for 9.
You what? But those are like angle 2 equals 6, angles 4 equals 8, and I think that's about it. Yeah, okay. That's number 1. Number 2, alternate interior angles. Which angles will those be? Those are congruent as well, they're equal. So alternate interior. Angle 3 is on the inside. You see that? Which one is equal to that angle, you think? That's also on the inside. Which angle look like it's the same as this angle right here that's on the inside? Remember, this is the inside. This is out. And this is out.
6.
Yeah. And there's another one. Angle 4 is equal to.
5.
Okay. All right. Number 3. Alternate exterior angles. Those are also equal. So that one will be angle 1 is equal to what? Angle 2 is equal to what? What do you think that's gonna be? Oh, well, angle 1 is equal to angle 8, right? Because they're on the exterior, which means out, right?
Yeah.
Angle 2 is equal to angle
7.
7. Okay. Number 4. Move this over just a little bit. Let's see if I can. Yeah, that's okay. Number 4. Number 4 are going to be consecutive interior angles. These are the only angles which add up to 180 degrees. Do you see that?
Yeah.
Okay. So which angle will that be? Consecutive inside. Angles on the inside. Angle 3 plus what equals 180 degrees? Consecutive means on to next to it. It's next to it. What angle is next to 3?
4.
No, not like that one. It has to be 5.
Oh.
Okay. Angle 5. 3 and 5. Do you see that? 4 plus
6.
equals 180 degrees. You see that? Okay, the very last one are called vertical angles. Are you writing this down? Vertical angles are also equal, and they're the one that makes the axis. Do you see how with this vertical angle, it's this one right here? I know this is hard for you, but if you don't practice, you're not going to get better on this. Do you see the vertical angles like that? Do you see that? So which one do you see there are vertical angles? Angle 1 is equal to what? Angle 2 is equal to what? Angle 5 is equal to what? Angle 7 is equal to what? Look for the axis. Do you see how 1 and 4 are axes? Do you see that? 2 and 3, 5 and 8, 7 and 6. Do you see that? Okay. All right, so let's go ahead and try this one then. First things first. Do you see how they give you 143 right there? Angle B is also 143. Why is B 143? Because they're vertical angle. Do you see the X sign that we have there? Okay, so what angles do you need to find here? You need to find angles A, B, what else? C, D, E. Is there F? No. There is E. There's K, H. No, there is F. Just kidding. F, G, H. There's an angle M. There's an M. And there's a P. Is that an S? What is that right there? You know what that is? That right there? This one? Is that an angle?
I can't tell what that
Is
is.
that angle S? Let me throw a question mark. Okay. So anyways, we have B is equal to 143, right? B and A, do you see how they create a straight line? So then how do you find A? Straight line is 180, isn't it?
Yeah, which is 37.
Yeah. Okay. So we got A and we got B. C. C and A, they look like they're the same, right? But which one is that theorem? Is it 1, 2, 3, 4, 5? Look, C and A.
Damn it.
They're on the inside of the parallel line. So which one is the interior?
Alternate interior.
Interior. So they're equal, right? Because A is acute and C is acute, right? So if A is going to be 37, then C is going to be 37. So angle C, 37 degrees. You need to copy this right down first. So I'm going to give you a moment to copy it down before we go any further. Okay, so then C is that. So then D is right here. Okay, so do you see how C and E are vertical angles? So C is 37, E is 37. Do you see that? Okay, now for D, how can you find D? Do you see D, E, and 85 are a straight line? So then for you to find D, you just take 180, which is straight line, minus what?
85.
And there's another straight line that makes it. There are 3 angles that makes a straight line. You see the 3 angles?
37.
Yeah, you need to make sure you have that too. Which gives you what? Okay, now looking at this next one, I suggest you look at E, F, and the right angle. What can you do with F? How do you find out? You're gonna go with me. Yeah, you're gonna go with me. It's just one down the street. That's it. I'm making you tamales. Just get it done. Where's you're going to? But it's just gonna be down the street. Okay, so then looking at F, you see, or do you already find E? Yeah, we do. E is 37, right? Now look at F. Do you see how this one creates a triangle? Do you see that? In the triangle, a triangle, all the angles add up to 180. So do we have at least 2 of the angles? Yeah, we have the 2 of the angles. So 180 minus 90 is the first angle, and then 37 is the other angle. Do you see that? Okay, so now subtract it. What does that give you? Actually, what you can do is, 180 minus 90 is just 90. So it's just 90 minus 37. So that should be easier. Which then gives you 53.
Yeah.
53. All right, so F is 53, right? Do you see how F and H, they're not vertical angles because you see that it doesn't create that perfect dax? Do you see that? Some people might think that it is, so I just want to make sure you're careful with that. Let's see, what else can we find? We said that, let's see, what else can we find here?
What's wrong with you guys? You just garbage everywhere.
Good. Good.
Okay, we're kind of stuck here, Silas.
Good,
Silas, we need some help.
good, good.
I'm kind of stuck. I'm not quite sure how to find some of the other ones.
Which one are you trying to find?
Trying to find either this one, or this one, or this one, or this one.
Don't get it.
Okay, well, you're gonna have to study a little bit more on this, aren't you? If I can get one of these, that'll be great, but I don't know. And I can't figure out what H is, because you know. Hey Grayson, if you get stuff like this, one thing you could do is I'm just gonna assume that this angle is, I mean, when I look at it, what shape does it look like? It looks like it's a cube, right? So I could say that this right here is 80 degrees. Just assume that and then find the other one, okay? Do you see it? Because I can figure out what C is. I know what C is. And if I know that, then I can do a quadrilateral, but I don't know these two. I know these two add up to 180 degrees, but I don't know one of them. Although I do think that this line here and this line here are parallel. And we have a transversal right here. So let's see. But that doesn't help me with anything. Oh, maybe it does. If this angle's 48, I think this angle is 48 as well. Can you see that? Or no, it's not. Just kidding. No, it's not. Do you see how we can find anything? Hmm?